Hello, everybody. Today is third US. So operator of physical quantities of a particle system. So particle physics is a branch of physics that deals with a basic element of the radiation and the interaction between them and the world particle can refer to various types of very small objects. But this branch is usually in states as detectable particles, and particle physics is also known as high energy physics, as many elementary particle with can only be during the energetic collision of the particles, and so elementary particle physics is there are only four types of interaction that exist between the elementary particle, and they are gravitational interaction and the electromagnetic interaction, strong interaction, and weak interaction. So gravitational interaction is associated, the interaction range is infinity, and the gravity interaction is characterized by the interchanging nature of the particle and the exchanging of particles, and the orientation of the object is dependent of the velocity, and the weak interaction is mainly involved in nuclear DC, like beta DC. It's also exchange particle nature, and the particle changing is so electromagnetic interaction is electromagnetic interaction release of the object change, and it also has a characteristic of the particle on the position is the exchange particle, and strong interaction is it also depends on spin, and is a spin. The strong contract also relied on the objective's velocity and direction. It also exchange the nature of particle, and it changes particles like nuclear interaction, and so it's the interaction is strong and load depend. Types of elementary particle on the basis of spin, there are two types of elementary particle. They are boson. This follows boson. B point is state statics. They have a symmetrical wave function along with an integral spin, and so lepton and bryons are part of fermions. So lepton are known for participating in weak interaction and the not strong ones, and they are also known for electromagnetic interaction. So they are, however, avoid weak interaction. A standard model of particle physics, how can we see in this photo. So the standard model of particle physics was developed in the later half of the 20th century. It was a collaborative effort of many science around the world, and it's story related to the electromagnetic nuclear interaction, and also classifying the subatomic particle. And the development of the standard model was driven by a theoretical and external particle, and this model consists of 61 elementary particles and 24 fundamental fermions and 12 particles, and they are associated antiparticles with our major components. So, particle physics formulas, how we can see in this graph, have a quantity, a definition equation, and simply use it, and their meaning number of atoms is n0 equal n plus nd. Here, n is the number of atomic number of atoms remaining at time t, and 0 is the initial number of atoms at time t, and d is a number of atoms decayed at time t. So mass number A equals Z plus N. Here A is the atomic mass and atomic number equal, so here N is the number of neutrons, Z is the atomic number of protons or number of neutrons. So radioactive decay, dt divided dt, dn divided dt equal minus lambda times n times n equal n0 times E minus lambda times t degree. So here n0 is the first number of atomic, and here number of atomic time in t. Here is a time. Lambda is a decay constant. So particle physics, conservation law, they are main types of conservation, two types, and they are exact conservation law and approximate conservation law. So exact conservation law is if these law are violated in nature, the reaction is not permitted. The law of exact conservation include energy conservation, momentum conservation, or angular and change or charge part-time conservation. Approximated conservation law is violated when the reaction may or means premated. Is this being the entire combination of it is being like this. Uses of particle physics. They are multiply uses of particle physics in different field or across sciences, across the science. They are particle physics or is employed in a product of medical isotope used in perimaging and external radiation. So helps to get the concept of superconductor, and the other domain of application of physics are development, medicine, industry, science, and the national science, and etc. So thank you for attention. Bye.